Hello, namaste. Welcome back to our channel Gen Z Learn. Today we are going to learn one of the most important Python interview topics, Factorial. Without wasting our time, let's go into the questions. Firstly, we'll learn what is Factorial in this because it was a main important question in the interviews. It need to be learned today. So, what is Factorial? Factorial is it's a number is a product of all positive integers from n to 1 to the number which is given by the user. So we'll write the definition first. Factorial of a number is the product of all positive integers 1 to that number. Okay. This is the definition. And we also have a formula here to find the factorial of a number, which is so simple. N factorial is equal to n into n minus 1 and into n minus 2 and into so on 2 into 1 like that. So basically, what do you know about a factorial? Generally, factorial is the one which we multiply the numbers which are behind them, in front, like backside of them. Like if we have a number called 10 factorial, if we think we have 10 factorial. So to find this, we need to multiply the numbers called 9 into 8 into so on up to 1. So it becomes the factorial, right? So in this, generally we have if we see 0 factorial is 1 obviously, and also we have if we have 1 factorial is also 1. These two are the default values which are used in the factorial. So for the next things like 3 factorial or yeah, if we see another factorial numbers like 3 factorial, it will be the multiplication of 3 into 2 into 1, and the answer will be 6. In the same way, every number is calculated in this way. So uh, basically we have questions in this. So what's our main theme is, in every interview, each and every interview question, we will be having multiple questions in it. So to discuss those questions in a deep and clearer way, so Gen Z Learn is planning to do all this series. So we'll see what is the questions here we gonna learn. First one is, find the factorial of a number. This was the basic question which we know about the factorial question. And second question, find the factorial using loop. This is also a most important question because we don't know how interviews could be done, how they ask the questions. So we need to get prepared for all the aspects of the codes, right? Next one, find the factorial using recursion. Okay. Next, fourth question, find trailing zeros in factorial. Fifth question, find factorial without recursion. Sixth one, store factorials from 1 to n. So these are the basic questions which are asked inside the factorial. We'll learn its steps, the logic, the code with explanation, and I also like to dry run this time. So let's get started with the first question. So finding the factorial of a number. In this question, basically finding the factorial, we need steps to find out. Firstly, we need we need to read the number from the user. You can take a starting number also. Second, take factorial is equal to 1. You need to initialize the variable, right? And third one is just multiply factorial with every number from 1 to n. Then finally, you need to print the factorial. Print factorial. Okay, we used factorial variable, so I'm not confusing you. Well, coming to the logic of the code. Here, firstly, we need to take the factorial to the 1, right? Initialize factorial to 1. Next, you need to repeat from 1 to n. Repeat from 1 to n. Just I'm writing a logic, basic logic here. It's not in steps. Factorial is equal to factorial into I, because I is in the range of the repetition here. And finally, you need to print factorial. Right? So this is the logic of the code, which is most easy and simplest way among all of the codes. Let's go to the code now. By using these steps, we are going to do the code. Take the input from the user. N is equal to int input. You need to enter a number, right? Input is taken. What I have said here in the second step, we need to take a factorial, which is equal to 1. That means we need to initialize factorial to 1. Factorial is equal to 1 is initialized. So here we need to use a for loop, because you may get a doubt that we have a second question using a loop. Then why you use the loop in the first question? Because finding factorial of a number generally uses a loop here. So in this, firstly I will be saying about the for loop in this, and second one I'll use a while loop there to satisfy the loop question. Okay. So for I in range of 1 comma, we need to start from 1 and end at n number plus 1, because in this loop, in this range, if we just write num, then it ends at the before number, which does not include the num itself. Okay, if we increment the number here with plus 1, then it stops at the exact num number. So that's the reason we need to do increment here. So factorial is equal to factorial into I. So this is the most important thing here, which is the main basic logic of the code here. So you should remember it. Print factorial. Factorial, just will write here. Factorial. Factorial is not factorial. Yes, our code is correct. We'll enter factorial of 3. Factorial of 3 is 6, as we know. Yeah. So if we take an input called 5, okay, we'll run it again. If we take input called 5, initially factorial will be initialized to 1, right? So I will be initialized to 1, factorial will be initialized to 1. Then here 1 is stored in the factorial and 1 is stored in the 1. So 1 into 1 will be stored in the factorial, that is 1. So now factorial is updated with the value called 1. And after that, this factorial value 1 will be again given to this. So factorial is 1 and range in second place. So 2 here. So I is 2. 1 into 2 is 2. Factorial is initialized with now 2. So like that, 1, 2, 3, 4, the loop continues until the number we have mentioned here. If we want to dry run this. Just I'll give a table for you here for better understanding. If we took an input of 1, right, and initially factorial will be 1, right? We have initialized that. So here, let's use here we have I, here we have fact, right? Again here 1, 2. If it is 1, then here it becomes fact is also 1, initialized to 1. Just I'll do what is 3, 4, 5. Okay, we need up to 5. So factorial of 5 is needed for now. Okay. So when this is 1, factorial will be 1. When this is 2, factorial becomes 2. And 3, factorial becomes 6. 4, factorial becomes 24. And next 120. So final answer we get is 120. So output will be 120. Okay, this is about the first question. Let's find the second one. Find the factorial using loop. So here, I have mentioned you that we have used for loop in the before question. So now we are going to use the while loop in this question. So let's start with the steps. Renumber as usual. Factorial need to be initialized to 1. And here start I is equal to 1. Okay. Multiply till I is less than or equal to num. Okay. Next one, increase I. This is the steps which we gonna do now. Logic is simple. Just we need to take factorial is equal to 1. I is equal to 1. Fact 1. I 1. And while I is less than or equal to num, then factorial is equal to the we have used it, right? I factorial into I. Then you need to increment the factorial. Okay, you need to increment the factorial. This is the logic. Yeah. Well, coming to the code. Generally, as usual, input is taken. Factorial is initialized to 1. Let's take it as fact. It becomes C. And you need to initialize I is equal to 1 because here we are not using for loop. We are using while loop here. You need to increment after the while loop, like inside the while loop, it need to be incremented. So instead of for loop, we are taking the while loop. While I is less than or equal to num. So factorial fact is equal to fact into I. Okay. After after this process, every time the I need to be incremented. So it checks the every number I equal to I plus 1. We have a shorthand form also like I plus equal to 1. But I prefer using normal form because I literally get easy with this and print factorial. Enter the num 3, 6. Why I'm entering only 3 is you get easy clarification by that. Factorial of 3 is 6 and factorial of 5 is 120. Okay, the while loop keeps multiplying until it reaches the entire number. So that's why we use here while loop. So next question. Factorial, find the factorial using recursion. This is the main important question, guys. So focus on this mostly because recursion is the most important topic which is asked in every interview questions, which needs like a very powerful coding here. Not it's not so heavy, but it's powerful. That's it. So here basically recursion is nothing but a function calling itself is called recursion. It's a simple definition. Uh, well, coming to steps, we have a simple steps here. If you move once, you feel recursion is the easiest one than the loops, other things. If num is 0 or 1, then you need to return 1, right? Otherwise, otherwise return a simple formula is there. You need to just remember it. You need to return what you need to return num into fact of num minus 1. Okay. Every time this formula will be called and it will be calculated and it will give the factorial number. So that is called recursion. While coming to the logic, it will be so good logic is. So if we say factorial of 5, right? Then what happens here is, yeah, here 5 will be first multiplied and write this 5 into factorial of 4, right? And next, now 5 is multiplied, now 5 into 4 into factorial of 3. Again 3 need to get included in this 5 into 4 into 3 into factorial of 2. Now 2 need to included in this. So 5 into 4 into 3 into 2 into factorial of 1. So while it reaches the factorial of 1, generally what we know here, if the number is 0 or 1, return 1. So factorial of 1 returns 1. 5 into 4 into 5 into 4 into 3 into 2 into 1. Okay. So the final answer will be 120. You remember this? It's very, very easy thing and very important one. So remember it. Yeah. By using this, you need to do the code. So basically for factorials, you need to have a function here. Def factorial fact, just we call it a fact, which take n as input if, as we mentioned there, n is equal to 0 or n is equal to 1. Then what need to be done? Then return 1. If we are writing here, it comes under the else part. So you don't need to write specifically else do this. Okay. So you could directly write return n into fact of n minus 1. Okay. Now you could take the num input from the user, enter number, right? So here you need to print the factorial, print factorial is factorial of num. So this num is included here, so it generally does the process here. Right, it's fine. We'll see which I have. 120. Okay. So, okay, if you have any doubts, please mention in the comment section so I could improve my like explanation, or if you want any other things also, you could just comment in the comment section. I'll be trying to do everything what you want. Next question. Find the trailing zeros in factorial. Generally, trailing zeros are nothing but are the zeros at the end of the factorial. So if, for example, if we have 5 factorial is equal to 120, so we have one trailing zero there. Okay, shall I write here? 5 factorial is equal to 120. So we have one zero here at the ending. So we could say one trailing zero is present. Or if we take 10 factorial for your clear understanding, we got there before we have done, right? So we got 3, 6, some 2, 8, 8, 0, 0. Yeah, let's see. So here we have two trailing zeros. Have two trailing zeros. So this is the main thing. Trailing zeros are nothing but the zeros which are at the end of the number of factorial. So we're coming to the logic. Generally, okay, while coming to the steps, firstly you need to initialize the count to 0 and next divide the number by 5. Why we are dividing the number by 5, this is gonna explain in the next, like in the coding part I will be explaining it. So divide the number by 5, add coefficient to count variable. Okay, and next you need to multiply the divisor by 1, sorry, by 5 each time, like 5, 25, 125. These are the most important numbers. So, and next finally print the count. Okay, so these are the steps here you need to follow. Initialize count to 0, divide num by 5. Why this 5, like why we use here 5 for division is just like we want to find the numbers which are having zeros at the end, right? Basically 2 into 5 is 10, right? So maximum of the in case 2 will have more number of factors. Okay, since there are always more 2's than 5's, count only the number of 5's in the factorial. So that's why we are using here 5. While coming to the logic, every zero comes from 2 into 5 is equal to 10, right? Since so I have said you that since there are always more 2's than 5's, count only the number of 5's in the factorial, which becomes easier for you to write the code. Yeah, while coming to the coding part, yes, I'll explain you line by line here. As we took here num is equal to int input by entering the number, enter the num, and we need to initialize count to 0. I have said you, right? After initializing count to 0, I need to be set to 5. Okay, I need to be set to 5. While num I greater than 0, here you need to count and it need to contain count plus num slashes I. Okay, I will explain you this. I is equal to I into 5. Finally, you need to print the count. trailing zeros are okay, will be printed here. So what was happening here is, firstly, I get, yeah. Like, what is the purpose of the code? I want to say you. So here, what is the purpose of the code is, this program finds how many trailing zeros are present in the number. Okay, which the number you will be writing here, right? Like, you will write here factorial, 5 factorial you wrote. So how many number of zeros are present in the factorial value number? Here we have 1 0. Okay. If we take here 10 factorial, 10 factorial, then we get two trailing zeros, because the answer of 10 factorial is 3628800. So we have two numbers. So there are two trailing zeros. Instead of calculating the huge factorial, this program counts how many fives are present in it. Okay, just a simple logic here, just finding the how many fives are present here. We could know the trailing zeros. In the line 1, we took the input from the user, and in the line 2, we, like, this variable stores the total number of trailing zeros here. So initially count is initialized to 0, because we haven't counted anything yet. In the line 3, I is like initialized to 5. We start checking multiples of 5, because every trailing zero needs one factor of 5. Okay, you got this now? Like, we start checking multiples of 5. 5 multiples need to be checked, because every trailing zero needs factor of 5. Initially it's 5. And in the fourth line here, we have a while loop here. This checks whether there are any numbers between 1 and num that are divisible by 1. Okay, 1 and num that are divisible by I. And here we have the two slashes, which means that it neglects the decimal values. After the decimal values which are there, those will be neglected, and the only before decimal values will be counted here. So if for example, if we took 100 here, and I is n is equal to 100, and I initialized to 5, right? So 100 slashes 5, here we get 20. Okay, in 5 table 100 goes 20 times, so we have 20 trailing zeros in number 100 factorial. Okay, so that was the main logic here. So 20 is greater than, here we get 20, right? 20 is greater than 0, so the loop runs here. Okay, the loop runs here. Once it checks here with 1 2 3 4, and loop runs here, count will be initialized. And again what is happening is, why only 100 slash 5 is equal to 0? Why we got that is, the numbers divisible by 5 are, I want to write it first. We got 100 and 5, which is equal to 20. I have said you, right? So here how it is helping us, that is, the numbers divisible by 5 are 5, 10, 15, 20, 25, like that, so on up to 100. We have 20 numbers. Okay, 20 numbers are there. So that's why we are getting, so each contributes at least one factor of 5, right? So that's why we are getting 20 here. And in the next line, fifth line, we have count is equal to count plus num, what this slashes I. This means count will contain the value of this expression. So count is currently 0, and this expression num slash I slashes I is equal to 20. So 0 plus 20 count stores 20. Okay, here count stores 20. Well, coming to the next line, we have I is equal to I into 5, right? So what is I here? Firstly, I is 5 here. So 5 into 5, 25. Firstly, with 5 it is checked, we get 20. And here after multiplying 5 into 5, we get 25. So I is initialized to 25. So here again, here in this place, I is taken as 25. Here again it is checked now. In the second iteration, 100 slashes 25 is taken, while the result will be 4. Okay, when we divide this 125, we get 4. If we have any decimal points, it will be removed because of this symbol. So 4 is greater than 0. Yes, it's satisfied. Then again the loop runs, again the count is incremented. So why 25? Why we have taken 25 is that numbers divisible by 25 contain one extra factor of 5. Okay. In first one, when we took 5, the number divisible by 5 will contain the factor of 5. Then here also the number divisible by 25 will contain one extra factor of 5. That's why those numbers are 25, 50, 75, 100, like that. So total is 4. So count becomes now 24. Again we need to do here. Again we need to, we got here 25, right? Again we need to come here. Again the same process will be continued. And in the third iteration, when we have here 125, after the next like incrementation, after the I is updated at the last time, we get 125. So here 100 slashes 125, which results in the answer of 0. So which is the condition is not satisfied here. 0 is greater than 0, which is false. So the loop stops here. Finally, we get the output called count. How many zeros are there? The increment is happening here, right? For first two, 5 and 25, it has satisfied and the count is being updated. So two times the number zeros are present in the number. So count is updated here and the output is printed here. So this was about the like counting numbers, counting zeros here. And we also have another thing, factorial without recursion. Factorial without recursion. Here in factorial without recursion, we directly do the steps code because it's not so hard like the other ones. If we know the logic at once, so it's so simple. Let's write the code here for factorial without recursion. We need to take the input as usual, and fact need to be initialized to 1. And for I in range of num comma 0 comma minus 1, which this line explains that I is in the range of number which starts with a number, and this point which says that it is going downwards, backwards. If we take num is equal to 5, then this makes this process to move backward, like 5, 4, 3, 2, 1, like that. So that's why this is used here. And next one, fact is equal to, as usual, formula type 1. And next, finally, we need to print. So I have said you right. It is so simple. Factorial 120. Okay. Just nothing but like loop starts from the entered number and multiplies down to 1. That's it. And while coming to the next one, store factorials from 1 to n. This is also a most important question. So I'll try to explain it clearly. So, like instead of finding only one factorial, calculate factorials from every number from 1 to n and store them in a list. This was the main concept here. So, while coming to the steps, I'll just give in brief steps here. Firstly, read n. Secondly, initialize fact to 1. And next, create an empty list. Create a empty list. Empty list. And next one, multiply. Continuously, you need to multiply it. Okay. Next one, store each factorial. Store each factorial. These are the steps here. Yeah, we'll go to code directly. Yeah, input is taken, factorial is initialized. Let's write it again. Okay. What they have said in the question, if you see, store factorials from 1 to n. To store factorials from 1 to n, we need to have a list. To store, we need a list. So that we need to have an empty list. Okay, empty list is created. So here we need to take for loop to loop from 1 to the number n. For I n range of 1 comma n plus 1. I have said you right, it stops at n position. If you take n plus 1. So you need to take n plus 1, it's mandatory. And fact is equal to fact star to I. And the result need to be stored inside the list. For that factorial, we need to append this factorial into the list. Okay, we did it. Finally, you need to print the list. Yeah, we can write up to 5. N is not defined. Sorry, your number I have left. Okay, we got the factorials up to 5. 1, 2, 6, 24, 120. Yeah. So, yeah, we have completed our third series called Factorial. I would like to give you a basic interview tips for this factorial question. That is, a common interview question is 0 factorial is equal to 1. Right? I'll write here. 0 factorial is equal to 1. It was a common interview question. And like next one is use a loop for simple and efficient factorial calculation. Use loop. Okay. Next one, use recursion to demonstrate understanding of recursive functions. Use recursion. Next, to find trailing zeros, don't calculate the factorial. Count factorials of 5 instead. Okay. Just count factorials for trailing zeros. Don't calculate the factorial. Just count factors of 5. And finally, when storing factorials from 1 to n, reuse the previous factorial, like fact is equal to fact into I, right? Instead of recalculating from scratch. So storing factorial for 1, reuse previous one. So I'll write this for you. So these are the important things. Yeah. And this is for today. If you like my explanation, if you like the concepts, and if you are interested more towards the technical and you have any doubts regarding any of the topic which I am explaining you, please comment down in the comment section so that I could clearly explain more concepts and I could clarify your doubts in the next sessions. Thank you for watching. Please like, share, and subscribe the Zen Z Learn. Thank you.